Hello everyone. Hello everyone. Let us see the concept called as super mesh. First, let us understand what is super mesh. When we call it a super mesh, if a problem is given, how to identify whether the problem is given is a super mesh or not, and how to approach the problem using a super mesh. So basically, a super mesh is formed when two meshes have a current source as a common element. Okay, so super mesh is formed when two meshes have a current source as a common element. That is called as a super mesh. So we'll see the problem, how to identify the problem. So just now I said that whenever the current source is common, it is called super mesh. Let us see how to identify that, whether the problem is super mesh or not, and then we'll see how to solve that problem using a super mesh. Let's take a problem. So a simple problem, we will take that and we'll try to analyze whether the problem is a super mesh or not. Let's see this first. Let's take a voltage source of 7 volts and a series resistance with a current source and one more resistance series to that. And here one more resistor. And let us give the values for the resistor: 1 ohms, 2 ohms, 1 ohms, 2 ohms, 3 ohms. And I'll give the nodes here so that it will be easy to analyze this problem. A, B, C, node D, node E, F, G, the last node is H. So here are the problem which is given with respect to the super mesh. I said that whenever the problem is given, we need to identify whether the problem is a super mesh or not. That is the first and foremost thing. We need to identify the problem is a super mesh or not. So here, as I mentioned, that if you look at here, there is a problem where I mentioned that the current source will be common to a two loops. If you look at a problem here, so this is a current source. This is a current source which is common to this loop as well as this loop. If you observe this, the current loop is common to, let me take this as a loop 1, I1, and this is my I2, and this is my I3. So these are the 3 loops I have. If you look at this current source, I will give the value for this. I forgot to give, it is a 7 amp source. A 7 amp source. If you look at this 7 amp source is common to the loop 1 and loop 2. So this, by looking at this problem only, we can identify the given problem is a super mesh, and I can apply a super mesh for this, so that the solving problem will be very easy for us. Okay, so let us see how to solve this problem. I need to apply KVL for the loop here. Before that, I will write the equation for this KCL equation for the common loop current source. KCL. Okay, so I'll be writing a KCL. So if you look at that, 7 amps current source is equal to, so assuming the direction I1, I2, the loop current I1 and loop current, the third loop current I3. So looking into that, I1 and 7 amps current are in the same direction. I1 is also in the same direction, and your 7 amps is also in the same direction. Hence 7 amps is equal to I1 minus, why I am taking minus, because if you look at this, the I3 is coming opposite to your 7 amps. I3 is coming opposite to 7 amps. So hence it will be minus I3. So this is the current equation which I got. Let me take this as equation number 1, which I got from this common current source with respect to loop 1 and loop 3. Now after writing the KCL equation for this current source, no need to consider now 3 loops, since I am eliminating this loop. I will be eliminating this branch, So once, because I written the current equation for that, so no need of writing once again the KCL, because I know the current, what is the effect of current I have written here. This 7 amps will be with respect to I1 minus I3. So hence I will not be writing the equation considering for this branch. So hence now the first loop I will be taking with respect to the points. Let me write the points. That will be KVL for point A, B. I will go to the diagram. A, look at here, A, B, H, A, B, H, from H to D, H to D, from D to E, E to F, F to G, G to A. So I'll continue this green line. So from here, A to B, B to H, H to D, D to E, E to F, F to G, G to E. This is my loop. So I'll be writing the equation for KVL for this loop. Since already I taken the 7 amps current source here, which I got from equation 1, hence I am eliminating this. I am considering I1, I3 or loop 1 and loop 3 as a one loop. Considering both the loops as a one loop, I am writing the equation now. So I'll be writing the equation here. That will be equal to, so if you look at that, I have a voltage source 7. I have a voltage source 7, which is a positive terminal, hence I have taken positive, plus 7, that is equal to, if you look at here, what is the voltage source? The first voltage source is this one, I1, 1 into I1 minus 1 into I2, because there are two current acting for this resistor. So loop 1 current I1 and loop 2 current I2, which is I2 is opposite, hence I have taken minus. And next coming to this one, 3 ohm resistor, plus 3. So plus 3, that is once again it is a I3 now. Look at this, the current, don't confuse, it is not I1 now, the I3, I need to consider I3, and it is opposite to which one? I2 also, hence it will be minus 3 I2, right? So then left out is this one, plus 1 I3, plus 1 I3. So there is nothing else resistor is left out. So this will be my equation for the loop, the point AB, the node A, B, H, D, E, F, G, A. If I simplify this, I will get equation as 7 is equal to, there are how many I1s? Only one I1, and I2 have minus 3 minus 1, it will be minus 4 I2. Then I3 have 3 plus 1, 4 I3. Let me take this as equation number 2. So now left out loop is this one. The left out loop is this one. I need to write the KVL for this loop, that is point B, C, D, H, B. So I'm writing KVL for that loop now. KVL for loop B, C, D, H, B. So look at this. The first resistor I will be taking as this one, 2 ohm resistor. It will be 2 into I2, because the current flowing is I2 over there, plus 3 into I2 and the current. So this is a current for 2 into plus 3 into I2, and there is also opposite current which is coming I3. So minus I3 minus 3 into I3, then I have plus 1 into this one, plus 1 into I2, plus 1 into I2 minus 1 into I1, because it is opposite to the current I1 also here. So this is my equation number 3. Let us simplify this. This is equal to 0. So let us simplify. The I1 is minus I1, I2 here 3 plus 1 4 plus 2 6 I2, 6 I2, then minus 3 I3 equal to 0. These are the 3 equations I have. Equation 1, so let me take this as equation 3. Equation 1 here, 2, 3. So in all that equation I have I1, I2, I3. So 3 unknown equation. Use your calci, okay, using your calculator. Solve for equation. Solving equation 1, 2, 3 by making use of an unknown equation. We get I1 is equal to 9 amps, I2 is equal to 2.5 amps, I3 is equal to 2 amps. So this is a solution for the given problem using a super mesh analysis. So this is how we need to write a problem. So just it's a super mesh analysis. So whenever this kind of problem are given, whenever the current source is common for two loop, we say it's a super mesh analysis. Okay, so thank you everyone.